Hey everybody, I'd like to welcome you to another Juice tutorial. And in this tutorial, what we're going to do is create a very basic delay effect. So this is almost like the hello world of delay effects. And this is drawing on our last tutorial where we created a circular delay buffer. And now what we're going to do is we're going to draw some audio data from that delay buffer and pull it back into our main buffer, creating this delay effect. Before we get started, just wanted to tell you about our audio programming community on Discord. We now have nearly 7,000 members. We hope that you can come join us. We have people from all over the world, all different experience levels. Come join us, theaudioprogrammer.com/community. Also, we connect with different companies to help provide opportunities for audio developers as well. And we have some of those listed on our jobs board. And that is over at theaudioprogrammer.com/jobs. So if you're an audio programmer and you're looking for a contract or permanent job opportunity, come check us out. So let's go ahead and get started. And I'm going to start off by giving a big shout out to Luca Greggio, who actually pointed out an error from my last tutorial on circular delay buffers, where he pointed out on line 175, previously I had channeled data for one of these arguments, and it should actually be channeled data plus num samples to end. And I have some details on that on the last tutorial, so if you want to dig into that a little bit more, check out the last tutorial. I'll put a link to it up in the corner, and you can find out more. So let's go ahead and get started. So I'm going to go over here to I'm going to go up here to the top just to review a little bit. So last tutorial, we built this circular delay buffer. The intention of this is that we have audio data from the past that we're going to store in another buffer. And then at a later point, what we want to do is we want to take that data and we want to pull it back into our main buffer that's going to create this delay effect. Now, last tutorial, we created the size of this delay buffer, which in this case is sample rate times 2 seconds. So this would be 2 seconds of sample time. So if our sample rate was 44,100 and we were multiplying that by 2, it would be 88,200 samples. So that would be an 88,200 index array. And that would actually be a 2D array if we were operating in a stereo situation, but I'm not going to make that too complicated for people who are just starting off. But just think of it as an 88,200 sample array if we were operating at a sample rate of 44,100. Okay, so it holds 2 seconds of audio. Going down here to our process block, which is where we're actually doing our heavy lifting and our audio processing, we have this function that we created in our last tutorial called fill buffer, where we actually are taking the audio that's happening at present and we're copying it to this circular delay buffer. And of course, we had to have some if and else statements just to check the bounds of the circular delay buffer, make sure that we're not running off the end of it, and that we're always staying within the boundaries of the data of the amount of space that we've allotted for this circular delay buffer. So now we've done that, and what we want to do is we want to grab some of this data back from this delay buffer, and we now want to add it back into our main buffer, and that's what creates this delay or echo type of effect. Okay, and what I'm going to do is I'm going to start off with some pseudocode just so we can get a high level idea of what we're trying to do here. So the whole idea of a circular buffer and copying this data is that we want to retrieve some data from in the past, right? So we have this variable that we created last tutorial called write position. And we can think of write position as where is our audio at currently, right? So I would just say, where is our audio currently? Because that's where we are, that's where we're currently writing, taking the audio and we're writing to our circular delay buffer. So I say this because write position you can think of as current position of the audio. Now we have this other position that some people like to call read position, which is going to be a position that's going to be in the past. Okay, so the whole reason that we have the circular delay buffer is so we can look in the past. Now, the delay buffer in this situation is 2 seconds of audio time. So what we might want to do, let's say that we wanted to look 1 second into the past, right? So from a high level, we could say that read position is right position minus 1 second in the past, right? Because we have 2 seconds to work with. Now, 1 second in the past, let's just substitute that, because we know that our sample rate is how many samples of audio plays in 1 second, right? So we know that this will mean sample rate amount of audio, or just sample rate, right? So if I say right position minus sample rate equals the read position, then what that means is that our read position is 1 second in the past from our right position, from our current position. So it's reading 1 second in the past. Okay? Now, if you're following along and you followed along to our last tutorial, you may realize something, which is that the right position may be at the very beginning, at the very first callback, the right position is actually going to be 0, right? And our sample rate is going to be, let's just say it's 44,100. That means that our read position would be negative 44,100, right? Now, how is that going to work if we're reading into an array? Because we know that the minimum that the first index of an array is 0. So if our read position is negative 44,100, how is that going to work? And the answer is that it doesn't, right? So what we need to do is something similar to what we did in our last tutorial, which is that if our read position is less than 0, we need to wrap it back around to the end of the circular delay buffer, okay? And you will see, I have some notes here. I've written most of them in cursive, so may be difficult for some people to read. But you'll see what I've drawn here, and this displays this example perfectly. So in this situation, for one reason or another, our read position is -2, right? So it's a negative index. We can't have that. And our delay buffer size in this situation is 512, right? So we have 512 size delay buffer and read position of -2. So since we can't read into an index of -2, what we want to do is we want to wrap it back around so that we end up with index 510. And we notice that last index is 511 because we know that in C++, an index of an array starts with 0. So 0 to 511 gives you a size of 512. So that's a common stumbling block for people who are just starting. So just keep that in mind. So taking this and then trying to pull a little bit of logic out of it, we can look above and we can see what this is kind of common sense, right? So now we just need to make it into a little bit of code. And we can say if the read position is less than 0, so in this situation, read position is -2, then the read position is equal to the delay buffer size, which is 512, plus the read position, which is -2, right? So I got this wrong before. I actually put delay buffer size minus the read position. You can see that I emphasized the plus sign there, okay? Because if you have a minus read position and your read position is -2, that actually turns it into a plus, which would mean that it would give us a position of 513, which is not what we want. We want a position of 510. So that's why it's delay buffer size plus read position when read position is a negative number. Okay, so that's what that means. So we can go ahead and just put that in here, right? So let's just start by writing this, and then later on we'll pull this out into its own function. So we can say auto read position is equal to the write position minus, we have this handy function called get sample rate, which gets our sample rate. And once again, this is 1 second of audio from in the past in the delay buffer, right? And then once again, we're doing that check. So we will say if read position is less than 0, we know that that would be an invalid index. Then we could say read position, and we'll just use a shorthand here, plus equals delay buffer size. Okay, that will ensure that we stay within the bounds of our delay buffer when we're trying to read back into the past. So now what we want to do is now that we have our read position, we know where we're reading from, we are going to need to do some checking again to ensure that our data, that the data that we're trying to read doesn't go off the edge of our delay buffer, that we wrap back around, that we do some logic to once again make sure that that's circular behavior. Okay, so let's start off with a simple, the most simple situation, which would be if the read position. So I want to go back a step actually, because I want to go back to high level again, right? So how much data are we processing per callback, right? So every time this process block calls, how much data do you think that is supposed to process per callback? Now, if you've seen my other tutorials, you would know that it is normally buffer size amount of audio that's processing, right? So each callback that happens, we are filling the main buffer with buffer size amount of audios. And that's normally a power of 2, but it's not always, but most times it is. So it's something like 256, 512, 1024, 2048. So it's normally that amount of data. So with that being said, what if our read position, so our read position is keeping track of where we want to read from in our circular delay buffer. What if our read position is towards the end of this circular delay buffer and that it doesn't have buffer size amount of data to actually copy, to actually move over to our main buffer? Then we're going to need to do a little bit of copy the rest of the contents from the remaining contents from the end and some of it at the beginning, like we did for the circular delay buffer that we did in the last tutorial, right? So let's talk about the easiest situation where that's not the case. So we could say if read position plus buffer size is less than delay buffer size, then we know that we're in a situation that is all fine, right? We know that the read position and that the read position plus the buffer size is still within the bounds of the delay buffer, and that we're not trying to go outside of the delay buffer size. So that's all right. Then what we could do is, once again, we have this nice function supplied by Juce called, we will do buffer.add from, not copy from. So you have copy from, which just copies and overwrites the data. Then we have this other one called add from, which actually adds the data rather than copies it. And I'm going to do add from with ramp. The reason I'm going to do that is because I'm going to have some gain. So a lot of times with delay, you have a little bit less of the volume on the delay effect itself is a little bit less, or sometimes it's filtered. There are all different types of things you can do with it. But in this situation, I'm just going to make it just a little bit less so we can make the delay effect a little bit more apparent. Otherwise, it'll just sound like two of the same signal. So I will make that 0.7. And then let's just start off with these different arguments. So we have add from with ramp. First thing is which channel of the buffer. Like I said, these buffers are actually 2D arrays. Okay, so we think of them conceptually or at a high level in terms of one-dimensional, but in a stereo setting, then it's actually two channels of that, which makes it a 2D array. Okay, so that's all right. Since we're already going through our channel for loop, we can just put channel in here to make sure that this iterates between 0 and total num input channels, which would be normally, that would be 2. So this will be iterating, channel will be iterating between 0 and 1. Destination start sample, so which start sample in the buffer, so that would be 0, right? Because we want to start at, we want to add in from the beginning of the buffer. The source, this one gets a little bit trickier, okay? Because what we're going to do is we're going to take the delay buffer and we're going to grab a read pointer. Okay, so read pointer just means that we're going to read it. We're not changing what's in the delay buffer. We're just reading what it is. Hence the names read position and write position. Okay, so we're just reading what it is, grabbing that. Once again, channel number is just going to be channel, which is iterating between 0 and 1. Sample index is going to be, what do you think it's going to be? Okay, needs to be read position, because that's where we're reading the data from. That's the starting point of where we're reading the data from. Okay, and num samples. Okay, so let's look back at our if statement. If read position plus buffer size is less than delay buffer size, so that means that we're okay in this situation to copy buffer size amount of samples. So here I can just put buffer size like that. Okay, and that's it. We're done there, right? So that is fine. But then we have this little else situation, which is where we don't have, where reposition plus buffer size is greater than the delay buffer size. That lets us know that if we try to copy buffer size amount of samples from the read position, which could be near the end of our delay buffer, then what will happen is that we're going to go into undefined territory, where we're going to try to read into memory that actually isn't supposed to be used for our for this buffer. Okay, so here we have another little a little situation, right, where I'm just using a just very small numbers just so we can conceptualize it easy. And we have a read position of 7. Our buffer size is 5, right? So we see that 7 plus 5 equals 12. But we see that our delay buffer size is 10, right? So we see that if we tried, if our read position, if we tried to copy or add buffer size amount of samples, that we would run off the end of our delay buffer. And that's not what we want to do. So from a high level, what do we want to do? We want to say, well, we know that if the delay buffer size is 10 and the read position is 7, that we have 3 indices that we can copy, right? So it's three indexes to the end. So that's why I have this here, 7, 8, and 9. The 7th, 8th, and 9th index of the delay buffer can be copied to 0, 1, and 2 of our regular buffer. And that is a variable that I've called num to end 3, right? So it makes sense. And then we say, well, how many samples do we have left that we still need to copy? Well, that would be the read position minus the buffer size, right? So 7 minus 5 gives us 2, right? So then what we want to do is take the 0th and 1st first index from the delay buffer and copy that to the 3rd and 4th index of our main buffer. Okay, so that's what we want to do. Now we just need to actually do that in code. So this is going to be 2 steps. So first thing that we need to do is determine auto num samples to end. We will set that equal to the delay buffer size minus the read position, right? Because that will tell us how many samples or how many indices are left at the very end of this array or of our buffer. And now we just need to do another add from with ramp. And then once again, this is channel. And then destination start sample. So we're copying to the first part of the buffer. So this will be 0. The source, once again, we want to get a read pointer from here. So it's delay buffer get read pointer. Once again, this is our channel. And then we have the sample index, which is, once again, read position. Now we get to num samples, right? This is the tricky one. How many samples do we want to copy? Or how many samples do we want to add to our buffer from our delay buffer? Well, that's num samples to end. That's why we calculated num samples to end, right? So num samples to end. And what I'm going to do is I'm just going to pull a little small local variable out for the gain. So I'll just call this auto g equals 0.7f. This will just be temporary. I mean, we could come back a little bit later. Oh, not GG, G. There we go. Just give this a little bit of a gain factor there. And so now we just need to calculate num samples at the beginning, right? So how much data we have left. So we could say auto num samples at start equals buffer size, because that's the total amount of data that we want to move or want to add from our delay buffer to our main buffer. Buffer size minus the amount that we've already copied, which is num samples to end, right? And then we could do, once again, buffer, add from with ramp. Then we have channel. Destination start sample, okay? A little bit tricky to figure out here because what's happened is that we started at 0, we copied num samples to end amount of data there. So we want our index to start at num samples to end, okay? So if we've copied num samples to end amount of data, let's say it was 3, so that would be 0, 1, and 2, which means that the next index that we would need to copy to would be 3, right? So that's why we have num samples to end and not num samples to end plus 1, okay? Then we have, once again, delay buffer get read pointer. And then once again, we'll just put channel here, and our sample index is going to be, let's think about this for a moment. It will be 0 because we're back at the beginning of the delay buffer, because we read to the end of the delay buffer and now we're going back to the beginning to read from there. And the amount of samples is num samples at start. And then the gains I'm just going to keep as that 0.7 for now. And that's it. We should be good. So let's go ahead and test this out. I've got Ableton loaded to launch when this actually builds. So here we are. We're in Ableton. And now we are loading, and now we will load our plugin. And I've put it on the track. And now I'll grab a sample. I'll grab this little drum beat. And just, if you have your headphones turned up really high, just turn them down just a little bit, just so I don't blow your eardrums out. And what we should hear is we should hear this beat, and then we should hear a slightly delayed beat behind it. Okay, so that works just fine, right? So let me just play it to you regular without the delay. And then with the delay effect again. So we see that this delay effect actually works just fine, right? So that's great. So, all right, so now we're just going to move this out into a function. All right, so this feels like enough of a body of work where we want to make this into its own function. So what I'm going to do is I'm just going to cut this from here. I'm going to create a new function. I will call this read from buffer. Just going to keep no arguments for the moment. We're going to bring some in just a moment. And then now we're going to create this function here. We're of course going to need some outside information in here, right? So let's figure out what we need to know. So right position and get sample rate, those are all member variables, so that's fine. We're going to need to know the delay buffer size. So we will say int delay buffer size. What else do we need? We need so we need buffer size, int buffer size. We also need access to our buffer and to our delay buffer and to our channel. So let's see, we will do int channel. I'm going to just take these and put these into an order I think is sensible. Buffer size, int delay buffer size. Then we need the buffer and the delay buffer. So this will be, let me go up here and I'm going to cheat a little bit. So this is a reference to our buffer. And then we're doing another audio buffer reference there to delay buffer. And anything else? I think that's good. Okay. What I like to do, what I've heard is a good rule of thumb is to put the larger objects at the beginning of the arguments. I've heard that that's convention. I don't remember where I heard that from, but That seems like a sensible rule. So I'm going to follow that. And then what I need to do is I've just copied all of that, and I'm going to then make sure I put it in my header file, or else it will not work. And then I'm going to do one more thing, which is going to be, let's test it again, but let's change the delay amount, right? So what if I wanted it to be a half second? So then it would be get sample rate times 0.5, right? And we will come back to this, and I'll actually make this into a real parameter that you'll be able to modify, but just to show you that this actually works. So here we go. So we're going to do half-second delay, and we are launching Ableton, and hopefully this will work. So we got an error. Oh, the error is that we need to put in these parameters. So buffer. Here we go. Read from buffer. So this will be buffer, delay buffer, channel, buffer size, delay buffer size. I could actually make this a little bit more concise and just calculate buffer size and delay buffer size in from the buffer and delay buffer that I pass in, but I'm not going to worry about that for now. And here we go. So we're loading Ableton, and now this should be a faster delay. Great. So that works. So I hope that you found that helpful. And that's really it. Any sort of feedback that you might have, please feel free to leave a comment in the comments below. Please be sure to give it a like and subscribe if you're not already subscribed to the channel. And I will see you next time.